Hey everyone, welcome to Simplilearn. Today we will learn join types in SQL. So joins basically help in many ways you can imagine to keep your database intact and improve your query performance. To understand this better, let's go through a small story or a use case imagining you run a database for a company securing the customer's data. So here goes the context. Imagine you are a SQL developer and you faced a critical issue during a project. Customer orders were mismatched with their delivery dates. The data was scattered across two different tables, orders and deliveries. Despite several attempts to resolve it, the mismatched entries created inconsistencies in the report. You realized you needed to understand how the tables were related and you turned to SQL joins for a solution. By using an inner join, you quickly matched orders with corresponding deliverables. Then, using a left join, you identified missing delivery information for certain orders. After analyzing the results, you pinpointed incorrect entries and updated the data accordingly. The reports were corrected and your team was impressed with your clean insights. You learned the power of SQL joins in managing relational data effectively. The project was a success and you felt more confident in your SQL skills. So that's it. If these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. For the delay, let's get started with our 1 point agenda for today's session, which happens to be the types of joins in SQL. So before that, let's understand what exactly is a join in SQL. In SQL, joins are used to combine rows from two or more tables based on a related column, or you can also call it as a primary key. They allow querying data across tables by specifying conditions that define the relationship. Joins are essential for accessing normalized data effectively in relational databases. Now, proceeding ahead, we will understand the different types of joins available in SQL. So there are multiple joins available in SQL, but the primary ones that you need to focus on are these five. So they are inner join, left join, right join, full join, cross join, right? And each of these joins will have a specific purpose in combining the data. Now, let's have an in detail understanding of each of these joins, starting with the inner join. So an inner join retrieves rows that have matching values in both the tables on specified condition. It only includes records where the join condition is true, excluding unmatched rows. So here you can understand this first circle to be as table A and the second circle to be as table B. Now where it finds a match, that means the common data entries in both the tables are the only ones to be extracted. So that's how an inner join works. Now the next one is the left join. A left join retrieves all rows from the left side table and the matching rows from the right side table. If no match is found, the results include null from columns from the right table. So you have so far understood the inner join, right? So it only presents the data entries which are common in table A as well as table B, right? Now, the left join is a little escalated or a little enhanced than the inner join. So it gives all the entries of table A, but along with that, it also tries to pull the matching entries from table B. Let's say you have got 10 entries in table B, which are in match with table A. So those entries are also pulled. That part of the table is also pulled in the left join. Now let's proceed with the third type of join, which happens to be the right join, which is completely similar to the left join, but the only difference is this time you're pulling the data from table B and the common values or common entries from table A, right? So a right join retrieves all rows from the right table and the matching rows from the left table. If no match is found, the result includes nulls for columns from the left table. Now, let's proceed with the full join or full outer join. Now, this acts like a bit differently, right? Whenever you wanted to club two different tables with all the entries, let's say the master data table has 10 columns, right? But for some reasons, you choose to split those 10 columns amongst two different tables. The first 5 to 6 columns will be in table A, and the next 4 to 5 columns are in table B, based on your requirements, right? Now, there comes a situation where you need all the 10 columns in one particular situation. So this is where you come across the full outer join or full join. So this particular full outer or full join does one thing. It combines all the columns from the A column or A table and all the columns from the B table and also the ones which are in common between both, right? So this is how a full outer join works. Now, the last type of join is the cross join. Cross join produces a Cartesian product of two tables, pairing every single entry of the first table with every single entry of the second table. So this particular image here will explain you how a cross join works. So the first entry in table A is matched with all the entries in table B. Similarly, the second entry of table A is combined with all the entries in table B. So this is how a cross join works. So far, we have covered the theoretical explanation of all the 5 joins present in SQL, starting from the inner join, left join, right join, full join, and lastly, the cross join. Now it's time for us to go a little practical. Now we will start the SQL workbench and try to execute some of the queries. Now we're on the SQL workbench, so our data is saved in this particular database, which is named as car dealership. And let's run the query. There you go. And let's also check our tables. So here you can have access to the tables, and these are the columns: order ID, state, region, customer ID, customer name. And if you close this, here you have your second table and expand the columns. And you have your columns here: order ID, delivery date, delivery days, and days to be delivered. Right? So you have two different dates: the order date and delivery date, and days to deliver. If I only, oh yeah, you have another section here where you can read, and category, product, fuel type, etc. These are the columns you have in both your tables, right? So you have a clean visual of your data table. Now let's start with our use cases. So we have mentioned our use cases here. So one for each type of join. So the first join is inner join as mentioned here. And now the inner join is identify customers and the products they purchased. We want to find the names of the customers and the products they purchased, ensuring the data exists in both customer data and dealership data. Now let's write a query for that. So the query will start with the select statement, and we wanted 3 columns here: the customer name, product name, and dealership name, right? So let's push them out, right? Customer name is the first column that we are trying to pull, and followed by that we have the product name that they purchased and dealership name. From the table, which happens to be the customer data. And remember, I'm using smaller case letters for the variables or the table names or the column names, and capital letters for the keywords, so that the reader can automatically understand what is what, correct? Now we want to perform an inner join with the dealership data. So you can just copy this and paste it here so that you can eliminate this and just write it down as dealership data on. I want to join on 2 primary keys, which is order ID. So to make sure that there is difference between the order ID from customer data and order ID from dealership data, I'm using this particular approach. So now customer data dot order ID and dealership data dot order ID. The query is done. Now let's quickly run this. Select this particular query and run. There you go. Now we have the data that we were looking for. There you go. So we were looking for the customer name, product they purchased, and the dealership. And here we have. Now let's proceed with the second use case. So now we will be performing the left join, and you are similar with the left join. Here we will be pulling out the data from table A, which is the first table, and also the matching entries from B table, right? Now list out all the customers, including those who have not purchased anything. We want to display all customers and any purchases they made. If no purchases exist, it should show as null for product and dealership information. Now let's write the query for this particular request. Start with select, and next we want to specifically mention the column is from customers table. So customer name as customer, comma. The second one is dealership data dot product as product purchased. Third column is dealership data, dealership name. Make sure you remember the names of the columns. If there is a small error in your column name, the query might fail. So make sure you keep the column names simple and rememberable. The table customer data, C, and I want to join now with dealership data. So use the join or left join since we are performing specifically the left join. And the left join is upon dealership data. So what you can do is mention the dealership data name here. It's D. On what condition? This is a different database. Don't worry. On the condition order ID. Customer.order ID is equals to the dealership.order ID. So we can simply place order C.order ID equals to D.order ID. There you go, semicolon, and the query is ready for execution. So select the entire query and run that one single query, and there you go. So we have the customer name, product purchased, and the dealership name as well. So the third use case is identify all dealership orders, including ones without an associated customer. We want to see all the orders processed by dealerships, even if there is no customer information associated with them. Now, for this, we will write the query as follows. Begin with select, as usual. Don't even if the MySQL Workbench gives you recommendations, don't choose that. Go with the use case thing so that you identify which is a keyword and which is not, right? Now, d.dealership name as dealership, comma, d.product as product purchased, comma, c.customer name as customer, from which table. So it will be from the table customer and customer data, and mention it as C, so that it is easier for us while writing the join query. Customer data C, and now we will be performing the join. So since we are specifically focusing on right join, use right join, and we are joining it with another table which is dealership data, and mention it as D, and the condition is on which columns C.order ID equals to D.order ID, and semicolon. Now let's quickly select the entire code and execute this. Now I have selected the entire code, execute, and here we have. So we have all the dealership orders, including the ones without an associated customer, and we have all the orders processed by those dealerships, even if there are no customer information associated with them. Now, moving ahead, we have our last but one, the fourth use case for today's session, which happens to be the full join. Okay, I didn't mention it here, so let me add it here as well. Full join or full outer join. Let's mention it as full outer join. And here goes the use case. So the use case is generate a comprehensive report of all customer orders and dealership orders. We need to complete dataset of all customers and dealership orders, even if they don't match. Now let's proceed with the code. So in this particular aspect, we might want to proceed with an union, but anyways, let's start writing the code. Select, tab, And what we can do is we can borrow the data from this code as well. So we want customer name as customer, and we want order ID as customer order ID. I think we missed a comma here. That's the error. Okay, not a problem. Now the next one is we want d dot order ID, dealership order ID, comma, d dot product as product purchased, comma, the last one, d dot dealership name as dealership, from which table I want it from the table customer data, and I will short term it as C. Customer data C, enter. I want to join this, so I'll proceed with left join with dealership data E on the terms, on the condition C dot order ID equals to D dot order ID. Now we will unite them by using the union command, and we will copy paste the same keywords or column names here. Copy and paste. Make sure everything is fine. We have customer name, order ID from customer data, order ID from dealership data, product and dealership date. From customer ID, sorry, customer data is the table as C, and I will be performing the right join, so both including left and right will complete as a full auto join. Right join on dealership data, copy and paste it right here, and the condition is the same as before. Order ID should be equal in both tables and semicolon. There you go. Now let's quickly select the entire code and run it, and we should be having our data here. So we have the customer name, customer order ID, dealership order ID, product purchase, and dealership. Now moving on to the last part of today's session, which is the cross join, and here's the use case. So the use case is create all possible combinations of customers and dealership products. We want to understand potential matches between customers and all available products in dealerships. Now let's proceed with the query for this particular request. So we will begin as usual with select statement. We are wanting to select customer name, product, and dealership name. So why don't we just take it from here, customer name, and we wanted the product name as well. So we will take product name and dealership name as well. And we want this from customer data C, automate as C for join. So we will be doing a cross join here for all the permutations and combinations, right? So basically the use of cross join is matching each and every entry of table A, the first table, with the second table, and the second table is dealership data D. Just paste it here, and that's our query ending. Now let's quickly run this query. Select the entire query and run. So there you go, we have the required data. So we have created all possible combinations of all the customers and dealership products, and we have understood the potential matches between customers and all available products in dealerships. And so far we have completed all the types of joins in SQL, starting with inner join, left join, right join, full outer join, and cross join. And with that, we have come to an end of this session on types of joins in SQL. And if you have any queries regarding any of the topics covered in this session, or if you require the resources like PPT, code documentation, or any other resource that is being used in this session, then please feel free to let us know in the comment section below, and our team of experts We'll be happy to resolve all your queries at the earliest. Until next time, thank you for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.